Assalamualaikum. Me and my team members will be presenting on a topic in subject MAT183, Calculus 1, which is application of differentiation. We have 4 members in our team. First, NURUL DANIA FATIHAH. Second, ARISSA HUSNA. Third, NURUL ATHIYYAH. And the last one, SYAZWANI.
Now, I will explain what is differentiation. Differentiation is a method of finding the derivative of a function. It is also a process where we find the instantaneous rate of change in function based on one of its variables. The rate of function is defined as dy dx, fx, and y. Now, I will pass to ARISSA HUSNA.
So, this is how we use application of differentiation. First, we find the related rates in the question. Second, we analyze the functions involved in the question. Third, we apply maximum and minimum problems. And the last one, we use Rolle's theorem and mean value theorem to find the answer.
So, in this presentation, we will present about the related rates. Related rates are rates of change associated with two or more related quantities that are changing over the time. The question should ask us to figure out the rate at which one is changing with the given sufficient information on all the others in the question.
So now, this is the steps in solving related rates problems. First, we have to find chain rule involved. Second, find the missing piece. Third, find derivative need. Fourth, differentiate. Last but not least is substitution. So this is our problem statement. The question is, an inverted cone is 16 cm tall, has an opening radius of 8 cm, was initially full of water. The water now drains from the cone at the constant rate of 22 cm³ each second. The water surface level falls as a result. At what rate is the water level falling when the water is halfway down the cone? Now I will pass to ARISSA HUSNA to solve this question.
I will determine the information based on the problem statement. Now we have height of the cone, which is 16 cm, and the radius is 8 cm. When the water is halfway down the cone, the height of the water becomes 8 cm. So now we have dV over dt equals to negative 22 cm³ per second. Since the problem statement states that the water drains from the cone at constant rate of 22 cm³ per second, so the volume of the water is decreasing. Thus, the value of the rate becomes negative. Now, we need to find the value of dH over dt, which is equal to dH over dV times dV over dt.
Alice will explain further. After we determine the information, we had an inverted cone as the image. We apply the volume of a cone equation to find the rate of change of the water level or height of the cone, which is V equal to 1 over 3 pi times R squared times H. By looking at the diagram, we can see that the radius of the cone is 8 and the height of the cone is 16. In other words, you can say the radius is half of the height of the cone. Therefore, the new equation as shown. Last equation will be V equal to 1 over 12 pi times H cubed.
Next, we will differentiate the volume of the cone, dV dH, and we will get pi squared over 4. Then, we have to substitute dH with 8 cm into the equation, and right now we have 16 pi as the result of dV dH. Then, we substitute all the answer into the equation. But first, we have to convert the dV dH into dH dV, so it will become 1 over 16 pi. Then, substitute the dV dt given, which is negative 20 cm³ per second, and multiply the dH dV and dV dt together. And the final answer is DHDT equals to negative 0.438 centimeter cube per second, where the rate of which the water level falls when it is halfway down the cone.
So next, we will be discuss about applied maximum and minimum problems. Applied maximum and minimum problems is the process of finding maximum or minimum values that is called optimization. Next, many application problems in calculus involve function to find maximum or minimum values. There are three steps in solving applied maximum and minimum problems. First, finding the derivative. Second, let the derivative equal to 0 and find the value of the variables. Lastly, second derivative test, which is if second derivative greater than 0, it will be minimum value. While if second derivative less than 0, it will be maximum value.
For the second problem statement, Encik Ali has 460 meters of fencing. He wants to enclose the rectangular paddock. For the question A, show that the length of the paddock is 230 minus S. B, show that the area of the paddock is given by A equals to 230x minus x squared. C, find the dimension of the paddock that will maximize the area. And last but not least, find the maximum possible area.
For question A, we will assume that the y is the length of the paddock and the x is the width of the paddock. So we will create a formula which is 2y plus 2x equals to 460. Since both the length and the width has two sides each of them. So after calculation, we got y equals to 230 minus x. For question B, the formula for area is x times y. So we just gonna substitute the value of y we got earlier from question A. Area equals to x times 230 minus x. Then we get to prove that the area is indeed 230x minus x squared.
Next, I will explain on how to solve the C equations where we have to find the dimension that will maximize the area. First, we have to differentiate the area and equate the dA dx into 0 so that we can find x, which is 115. Then, we use the second derivative test to determine the maximum or minimum value. Here we got negative 2, which means it is less than 0. Hence, it is a maximum value. Then, in order to find y, we substitute the x into the length of the paddock and we got 115 for y. Thus, x, which is the width, and y is the length, is both 115. Finally, for the D equations, we have to find the maximum possible area. In order to find the maximum possible area, we have to just substitute the x into the area equation, which is 230x minus x squared. And here we got 30,225 meters squared. Thus, the maximum area of the paddock is 30,225 meters squared.
Lastly, we may conclude that by applying the differentiation method to this problem, application differentiation can be used to define the volume value, solve any other kind of problem, solve problem regarding the volume value.